Hello, and welcome to Solving Quadratic Equations by Completing the Square. So, earlier in this playlist, I talked about two special formulas called perfect square trinomials. And the perfect square trinomial formulas are a squared plus 2ab plus b squared equals a plus b all squared. A squared minus 2ab plus b squared equals a minus b all squared. I believe you can find this in special factoring techniques. All right, so look for that video. But if we look at the right-hand side of these formulas, it looks like the form that we need for the square root method. Right, the square root property comes in. It'd be nice if we could take any quadratic and rewrite it in this form so that the square root property could be used. And many times we can. And this is the method, the process of completing the square. So what are the steps? I have no idea why this control is just hanging out in the middle of our screen, but it doesn't appear to be much I can do about it. So steps to solving the quadratic equations by completing the square. First of all, we're going to isolate all the variable terms on one side of the equation. I'm going to put them to the left. If the coefficient of x squared is not 1, divide both sides of the equation by the coefficient of x squared. All right, we'll get to that in examples, starting with example 3, I believe. Take half the coefficient of x, then square it. Add this number to both sides of the equation in order to keep it balanced. Solve using the square root property, and then check your answers in the original. So let's take a look at this first one. Okay, so first step, we want to isolate the variable terms on one side of the equation. So I'm going to add 20 to both sides. X squared plus 8x equals 20. Notice I left this gap here. Now, this gap, the coefficient of x squared is 1, so I'm good to go on next step. Take half of the coefficient of x. So I'm going to take half of 8, which equals 4, and I'm going to square it. So I'm going to add 4 squared to both sides. All right, so that's step 3. Step 3 in blue, take half of the coefficient of x. Half of 8 is 4. When I square the 4, I'm going to add it to both sides of the equation. So I did that specifically so that I would have a new equation, x squared plus 8x plus 16 equals 36, right? 20 plus 16. This left side can be rewritten as x, and then the sign that was in front of the 8x, so plus, whatever the half term was, 4, all squared. So if I can rewrite my variable terms as a perfect square, I can now use the square root property. Take the square root of both sides. I'll have x plus 4 equals plus or minus the square root of 36. I'm going to do one further step here. The square root of 36 is 6. So when I take this and write my two equations, right, x plus 4 equals 6 and x plus 4 equals negative 6. I don't have to simplify the square root both times. When I subtract 4, I'll end up with x equals 2. And when I subtract 4 in the second equation, I end up with x equals negative 10. Let's check it out. 2 squared is 4. 8 times 2 is 16. 4 plus 16 is 20. Minus 20 is 0. Check negative 10. Oh, it's going to hurt my brain. Negative 10 times negative 10 is positive 100. 8 times negative 10 is a negative 80. Negative 80 and negative 20 is a negative 100 to add to our positive 100 to make 0. So we could check our answers with these. Always check your answers in the original to make sure it works out. All right, let's try another example. So I'm going to rewrite x squared minus 12x. I'm going to take my 11 to the other side, and once it comes to the other side of the equation, it has opposite sign. I'm going to take half of 12. Actually, I'm taking half of negative 12. Half of negative 12 is negative 6. When I square it, I'll get 36. So I'm going to add that on both sides to keep my equation balanced. After adding 36 to both sides, I'll have x squared minus 12x plus 36 equals 25. And the whole reason I did this is so that I could rewrite it as a perfect square. Right? Perfect square trinomial is a binomial squared. To use the square root property, we know that the square root of 25 is 5. So I'll have two equations. X minus 6 equals 5 and x minus 6 equals negative 5. When I add 6 in the top equation, I'll get x equals 11. And when I add 6 in the bottom equation, positive 6, negative 5, I'll get x equals 1. Fantastic. Notice 6 halfway in between 11 and 1. So that vertex and these x values have a lot in common. Okay, so our first step in number 3, get all the variable terms on one side. Okay, that's done. I see that I have a coefficient in front of my x squared, so I don't want that coefficient. I'm going to divide everything by 2. In this case, that's not so bad. I just have to remember to do so. I almost wrote 16 again. Don't go too fast. You forget to do the little things like that division. Half of negative 8 is negative 4. Negative 4 times negative 4 is 16. So this negative 4, that's the important part. I'm actually going to end up with x minus 4 all squared. That's the whole reason I added the 16 in the first place. It's the exact right thing so that I can factor the left-hand side. And if I have 16 plus 2, I'll have 18. So this is x minus 4 equals plus or minus the square root of 18. Ooh, let's take a look at 18 though. 18 is 9 times 3. No, it's not. It's 9 times 2. I was thinking it's also 6 times 3, but we want a perfect square. Square root of 9 is 3. Square root of 2 is 2. So when I write my two equations, I'll have x minus 4 equals a positive 3 square root of 2, and x minus 4 is a negative 3 square root of 2. When I add 4 to both sides, I'll have 4 plus 3 square root of 2, and x equals 4 minus 3 square root of 2. Cut off my answer, both sides there. All right, fantastic. Let's do a couple more. And this is a great place if you would like. Maybe number 5 would be better. This is a great place to hit pause if you want to try a couple of these on your own before watching me do it. All right, so I'm going to move things around here. 4a squared, I'm going to subtract 20a from both sides. And then I'm going to move the 50 to the other side. When I move the 50 to the other side, I change the sign. And then I'm going to divide everything through by 4. Everything I'm going to divide by 4. Remember, this is the intermediate algebra approach. You'll get horrible fractions. You'll get worse values as you scale up through college algebra, pre-calculus, and so on. All right? Well, we're going to keep the idea straightforward, the number straightforward, so we focus on the concept here. A squared minus 5a equals 12.5. And that's a negative. All right, let's make sure. Let's just make sure. Negative 50 divided by 4. Negative 12.5. Okay. Now, I need to take half of negative 5. That's a negative 2.5. And when I square negative 2.5, I'm going to use parentheses to make sure I get my sign correct. Negative 2.5 squared is 6.25. So I'm going to add 6.25 to both sides. Add 6.25 to both sides. Okay, what do we have? Let's take this line and bring it up over here. I will have a minus 2.5 squared equals negative 12.5 plus 6.25 gives me a negative 6.25. But remember, we can't have a square equaling a negative. This says no real solution. That's leaving me, right? That's awesome. I'm using disappearing ink. I don't know where it went. No real solution. So I think to myself, how is that even possible? Let's try something. Let's graph this. 4a squared plus 50. I'm going to call it x squared. 4x squared plus 50. There we go. It came back on its own. Weird. I'm going to graph the right-hand side, 20x. Also, and what I'm looking for is where these two are the same. So if I were to just graph this with a regular window, I'm guessing I wouldn't see very much. There's one of them at least. Let's see. We probably just need to zoom out a bit. It's going to be more than a bit, but we'll need to zoom out a bit. Still not helpful. Let's change our window. My x values really don't need to change. Negative 10 to 10 is fine. My y values, I don't really care about the upper version. I do care about, the lower version. I don't care about the upper version. Let's see what's going on here. There's the parabola. There's the line. See how they never intersect? They never meet. They'll never be equal. That's what the no real solution means. And we can verify it by graphing the left side, graphing the right side, finding out when they're equal, when are they the same point. That answer is never. So, good job us. We got the right answer. I'm not going to even try to erase that no. Alright, so it's always a good idea to check your answers afterwards and make sure you didn't mess up a sign, right? It's everybody's, oh man, I always mess up signs. You can do this. You got this. Alright, so my variables are isolated. Let's divide everything by 4. Disappearing numbers again. That's awesome. That's so much easier on my brain. X squared minus 5x equals negative 2. Yep, it's disappearing there. There we go. Divide everything through by 4. This is not a negative 4. I'm going to use the eraser on that and actually take it away. Half of negative 5 is negative 2.5. And of course, when I square negative 2.5, I will get plus 6.25 on both sides. Yep, it's freaking me out too. Maybe it'll come back, maybe it won't. I don't know what to do here. So x minus 2.5 all squared equals 4.25. Let's see if I manage to write those clearly. I don't know, I was over here on the calculator doing something when the rest of them came back. No? Okay. I don't even know where I wrote last. So let me pause this and see if I can fix it. Okay, I have no idea how I fixed it. So that'll be fun. It looks like I kind of just overwrote, and I can no longer erase. All right, we're stuck. We're stuck right here. This is it. This is all I'm getting. X minus 2.5 equals plus or minus the square root of 4.25. I don't know about you, but I do not have the square root of 4.25 memorized, but I'm pretty sure it's going to work out for us pretty well. And I lied to you. Here's why. 4.25 is 17 fourths. The square root of 17 fourths is the square root of 17 over the square root of 4, which is the square root of 17 over 2. And it came back to me. I love it. Oh, my eraser worked a little bit. It decided to quit. That's all right. I'm going to roll with it. 4.25, if we rewrite it in fraction form, we get 17 fourths. And if you're unsure of how to do that, maybe if I entered the values correctly, the square root would turn out better. It would not. 4.25 math, answer to fraction, 17 fourths. The square root of 17 fourths is the square root of 17 over the square root of 4. We know the square root of 4, but we don't know the square root of 2. We end up with x minus 2.5 equals plus or minus the square root of 17 over 2, which gives us x equals, if we add 2.5 to both sides, let's see what happens here when it all just magically comes back. And there we have it. Now, I did something here. I didn't write two equations. I knew that I wasn't going to be able to combine like we had in earlier problems, right? The square roots, we can't combine them. So I probably wouldn't leave a decimal answer mixed with a fractional answer. I would most likely write this as 5/2 plus or minus square root of 17 halves. And that's going to disappear and come back just for no reason whatsoever. And this is what I would call my answer. This is acceptable. X equals 2.5 plus or minus square root of 17 over 2. But it's better if you have one fraction. Keep them both fractions. Right? It's easier to put the 2.5 into fraction form. Let's see if I can make that come back so it'll at least stick around when I publish these notes to my website. This is tripping me out. I think my computer's not really interested in working this early in the morning, so I'm going to call this the end of the video. I hope you enjoyed that little disappearing ink act that I had going on. I hope I can figure out why it's happening. Thanks for listening.